Good day, everyone. Welcome to our presentation titled Evaluation of Infiltration Rates of two different soil types in Nsukka. The abstract of our presentation is shown on this slide. Introduction. Infiltration is the process of water penetrating from the ground surface into the soil. It is an important component of hydrologic cycle. Water infiltration is a determinant of the amount of water that is available for groundwater recharge as well as plant growth. Many factors affect this infiltration, such as condition of the soil surface, vegetative cover, as well as the properties of the soil, such as hydraulic conductivity, porosity, and current moisture content of the soil. There are many ways to measure infiltration in the field, and also there are many models to estimate infiltration. Double ring or single ring infiltrometers are commonly used for measurement of in-situ infiltration rates. However, the double ring infiltrometer is often preferred because the outer ring reduces the error resulting from lateral flow in the soil. In Nigeria, particularly southeastern Nigeria, little is known about the infiltration characteristics of different soil types. No infiltration model have been developed specifically for this region, and existing infiltration models have not been fully validated in the region. Hence, this study aims to evaluate infiltration rates of two different soil types within Nsukka catchment and compare the results obtained in the field with that estimated using Greener Arms infiltration model. Two sites were selected for this study, namely Nsukka soil series and Ikpulogu soil series. They are located within the longitude and latitude shown here. Then within these different soil types, three plots were selected labeled A, B, and C. Double ring infiltrometer was used to measure the infiltration rates at different time intervals, starting from 5 minutes, 10 minutes, and 20 minutes until a steady state was achieved in those locations. Figure 1 shows a double ring infiltrometer with the inner ring having 30 cm and the outer ring having 60 cm in diameter. The 15 cm of this infiltrometer, double ring infiltrometer, was driven into the soil, and 12 cm part was left above the soil surface. In addition to field measurements, representative soil samples from each location were collected and soil properties determined in soil science laboratory. The soil parameters determined were hydraulic conductivity, porosity, effective porosity, waiting front soil suction head, and effective saturation, as well as the soil class. With obtained soil parameters, Greener Arms infiltration model was used to determine infiltration rate of each location of two sites. Equation 1 shows the Greener Arms infiltration rate equation, where equation 2 shows the cumulative infiltration. The equation 2 was solved using successive substitution method because it's a non-linear regression equation. Results obtained from the study. From the two sites, we have Nsukka soil series and Ikpulogu soil series. And from the three plots A, B, and C, so the results for Nsukka series is shown in figure 2, and that of Ikpulogu soil series is shown in figure 3. The infiltration rate of this A, B, and C, they have uniform pattern in the sense that it started, the infiltration rate was higher initially and gradually decreases until a steady state was achieved. Table 1 shows soil parameters results, with Nsukka soil series having soil class of sandy clay loam and Ikpulogu series having loamy sand soil class. Figure 4 shows the average measured and grain and arms infiltration rates for Soka series, while Figure 5 shows that of Mpulogu series. Here we'll try to compare the average infiltration rate measured in the field with that obtained using grain and arms infiltration model. So for Soka series is shown in Figure 4, and for Mpulogu soil series is shown in Figure 5. Now, looking at the two figures, Figure 4 and 5, it seems that grain and arms infiltration model performs better at the Soka soil series compared to that of Mpulogu soil series, because the two graphs tend to come closer for the Soka soil series compared to that of Mpulogu soil series. So looking at the infiltration characteristics for the two sites on the average, we have that initial infiltration rate, measured initial infiltration rate for Soka series was 1.26, and that of Mpulogu is 1.43. Then the steady state infiltration rate for Soka series is 0.48, and that of Mpulogu is 0.52. Then for the modeled using grain and arms infiltration equation, the initial infiltration rate was for Soka series is 1.82, and that of Mpulogu soil series was 1.36. The steady state was achieved using grain and arms for Soka series at 0.58, and that of Mpulogu 0.88. So in general, we can say that infiltration rate for Mpulogu series is higher compared to that of the Soka soil series. We recommend that further studies should be carried out, especially because this study was done during dry season. We recommend doing this kind of study in rainy season as well as in dry season, and also comparing different models as well to know if we can come up with a model specific for this region. We chose grain and arms infiltration because it's a process-based model, but there are other process-based models as well as empirical models. So we should try those other models here in the region to ascertain the one that performs better, and as well as using other methods of measuring infiltration rate. So the references for this study is also shown in this last slide. Thanks for listening.